So before I begin, I would just like to give a little introduction on myself. Hello, my name is Morgan Knutson. I'm currently a senior here at WIU with a double major in environmental biology and zoology. I graduate this semester, and next semester I will be attending the University of Kentucky and getting my master's degree in entomology. I'm currently under the advisement of Victoria Livingston in the Department of Biological Sciences, where I am studying heavy metal contamination in American bullfrogs, Lithobates, catesbeianus, in Nahant Marsh. On the right-hand side, you can observe an adult American bullfrog, and below that is a picture of an aerial view of the Nahant Marsh Educational Center that is located in Davenport, Iowa. To begin, I would just like to give an introduction on the study site because it is very important to understand the study site to understand the research that I am doing. So Nahant Marsh is a wetland ecosystem that is located in Davenport, Iowa, and it was a former waterfowl hunting club. And as a result of the history and the activities that occurred here, the site was contaminated with heavy metals. These heavy metals were found in the water as well as the soil and the sediments. The EPA came in, realized how high the concentrations of heavy metals were in this area, and this site became a Superfund project and was remediated in 1999. Currently, this site operates as the Nahant Marsh Environmental Education Center, where a variety of things occur here. They host summer camps for children to come to learn about animals, science, ecosystems, as well as this area serves as a recreational center for people to come and hike and just enjoy the scenery because it is a very, very beautiful place. This wetland ecosystem was screened in 2017 and 2018 for trace metals, including cadmium, copper, iron, nickel, lead, and zinc. Specifically, my research deals with the frogs in this area because frogs are the lowest order of vertebrate located in Nahant Marsh. Specifically, I'm studying tadpoles because heavy metals enter the frog system during the tadpole stage of metamorphosis. The frogs are the first secondary consumer in this area, and the tadpoles are specifically a great study specimen because they are a good indicator of what's going on in the environment. They feed off the substrate and the algae in the ecosystem, as well as continuously process water for respiration, and therefore their tissues are constantly exposed to pollutants, toxins, contaminants, metals, you name it. So the data that I collect on the concentrations of heavy metals in the American bullfrog tadpoles in this marsh will be used to provide a comprehensive characterization of the extent of distribution, as well as dynamics of the heavy metals in this ecosystem. My hypothesis states that if bioaccumulation of heavy metals is occurring in this marsh wetland complex, then heavy metals will be present in the muscle and organ tissue of the American bullfrog tadpoles. I had a couple of objectives in starting my research. The first one was to determine the heavy metal concentration of copper, cadmium, and lead in American bullfrog tadpoles in this marsh, as well as use the information I collected from my research to evaluate the extent of distribution of heavy metals in the food chain in this area. First, the tadpoles were collected from the marsh using a dip net method. They then were euthanized on site using MS-222, which is an IACUC protocol. It's a chemical that kills the frogs within about 15 minutes. The frogs were transported back to our lab where their masses and dimensions were measured. The specimens were rinsed with laboratory water, placed in plastic bags, and placed in a freezer until we could revisit them at a later date. When that later date arrived, these specimens were flash frozen with dry ice and ground up to a paste using a mortar and pestle. This is when chemical digestion begins using the acid and hot peroxide method per US EPA method 3050B. In simpler terms, different concentrations of nitric acid and hot peroxide is added in different increments until all of the organic material is done digesting in this specimen. So you know that it's done chemically digesting because at the top of the beaker, while it is chemically digesting, there's a layer of bubbles and these bubbles disappear. Once chemical digestion is done and all the organic material is chemically digested out of the solution, then filtration begins using a vacuum filter. This filters out all the inorganic material that is in the specimen. So you chemically digest the solution to get rid of the organic material and you filter to get rid of the inorganic material. So what's left is this clear liquid at the bottom of the beaker that has suspended base elements in there, or maybe metals if there is metals in the specimen. At this step, you run this solution that has these suspended base elements in it through the atomic absorption spectrum. Basically, it sucks up the solution and spits this solution, aerosolizes it, spits it through a flame, and it can, on the computer screen that's connected to this machine, tell us the concentration of metals that are in our specimen if we have metals in the specimen. We have yet to do this step for a number of reasons, one of them being COVID. Everyone's bad year for that, but we are hopefully going to find out some results from this very, very soon. So in 2017, WIU professor Victoria Livingston conducted an experiment on this research site in which concentrations of cadmium, copper, lead, iron, nickel, and zinc were found in the water and the soils. And these exceeded the national water quality criteria for aquatic life. She then revisited this site in 2018 and found heavy metal contamination in the aquatic vegetation. And due to these prior findings, I expect that heavy metal concentrations will be found in the frogs in this wetland complex. This is important for a couple of reasons. One, this is an area that migratory waterfowl come into, some of them being endangered, and they can get heavy metal contamination a couple of ways. One, if the frogs are heavily contaminated with metals, they can eat the frogs and get it that way, or they can live a similar lifestyle that the frogs do, for instance, ducks eating off the bottom of the ecosystem and get heavy metal contamination that way. So it is important to understand and find out if where this heavy metal contamination is in the food chain. I would like to thank the WIU Centennial Honors College, as well as the Department of Biological Sciences. Of course, thank you to my advisor, Victoria Livingston, as well as Dr. Roger Villadero. And thank you for your time.